All right, today we're diving into a really fascinating experiment that puts a colony of 1,000 ants up against a whole series of simulated natural disasters. We are about to see an absolutely incredible test of engineering, teamwork, and just pure raw survival instinct. So, really, the entire experiment just boils down to this one big question. I mean, a single ant is tiny, right? Almost insignificant. But can 1,000 of them, all working together, actually overcome forces that would just completely wipe out a single one? Well, let's find out. And here is the gauntlet they're going to have to run. The trials get tougher and tougher as they go. We've got an earthquake, then a sandstorm, a flood, a blizzard, and, yep, you read that right, it all ends with a zombie apocalypse. Let's see how they handle trial number 1. Okay, first up is a major test of their structural integrity. The whole colony is living in this special 2D nest, which is great because it lets us see everything that's happening. The whole setup is sitting on a platform that's about to simulate the shaking of a pretty serious earthquake. The moment that shaking starts, even on a pretty light setting, the effect is immediate. You can see the workers on the surface just scatter in a total panic. They know something is wrong. And below ground, all those brand new tunnels they just built are at a really high risk of caving in. But just watch how fast that chaos turns into this amazing, coordinated response. Some of the ants immediately get to work reinforcing the tunnel walls, basically shoring up their home against the shaking. When one section actually does collapse and traps an ant, a rescue mission starts instantly. They dig out their trapped buddy, and then they clear the entire tunnel, making it totally functional again in just a matter of minutes. It is just incredible teamwork. So they survived their first test, but now the colony faces two classic environmental challenges, one right after the other, a sandstorm and a flood. This is really going to test their ability to adapt and innovate on the fly. And this is where we actually see them learn. At first, you see the ants trying to cross the open sand, and they're just getting blown right backwards by the simulated storm. But they figure it out pretty quickly. By climbing onto these nearby sticks, they get a much better grip and can just march steadily right through the wind to get to their food. Okay, next up, the flood. Water starts pumping into the enclosure, and it creates this wide channel that completely blocks their path. They can see their goal on the other side, but now there's basically a river in the way. So, what's the plan? Now, you might expect them to just try swimming or maybe just get stuck and give up, but their solution is so much smarter than that. After checking out the situation and the materials they have lying around, they decide they're going to build a bridge. This moment right here is such a brilliant example of their ability to use tools. I mean, watch this. A single ant gets underneath a feather and just starts nudging it slowly but surely right towards the gap. It pushes the feather into the water until it spans the distance, and then the rest of the colony just calmly walks across. They literally engineered their own way to safety. For this next trial, the threat isn't something they can see or fight. It's coming from inside the nest itself. The temperature in there is about to drop, and drop dramatically, just like a sudden blizzard. This isn't about strength or engineering. This is a test of pure endurance. To make this happen, ice gets placed inside the nest, and that drops the temperature all the way down to 0 degrees Celsius. That's 32 Fahrenheit. For these tiny creatures, that is a massive and incredibly dangerous shock to their system. What's so fascinating here is what happens to their movement. They just slow way down. Now, this isn't a sign that they're dying. No, it's a deliberate biological adaptation. By moving as little as possible, they conserve precious energy, which lets them wait out the cold spell deep inside their nest. It's kind of like a built-in survival program just kicks in for the entire colony. All right, it's time for the final and most complicated trial of them all. The colony is about to face a full-on onslaught. They've passed a test of engineering and a test of endurance. Now comes the test of combat. It's a zombie apocalypse, which is represented by 3 different kinds of insect prey all getting dropped in at once. This will test their hunting, their defense, and their swarm coordination. And what's so cool is they use a different strategy for each threat, perfectly tailored to the target. For the big grasshopper, they swarm it, using their mandibles to hold it down while they inject venom. For the squishy waxworms, they don't even bother fighting on the surface. They just instantly drag them down into the tunnels to be dealt with underground. And for the swarm of fruit flies, it's just pure predatory instinct. They overwhelm them with sheer numbers. And this quote from the experimenter reveals another layer of their genius. they never, ever stop adapting their environment. As they captured their prey, they dragged it to these hills at the back of the nest, which they had already converted into a whole new network of tunnels just for food storage. They are constantly engineering their world. So, after that whole gauntlet, what did we learn? Well, it all comes down to their survival toolkit. They used collaborative engineering to repair their home, creative tool use to build a bridge, incredible biological adaptation to survive the freezing cold, and perfectly coordinated tactics to neutralize any threat. And that really brings us to a final thought. This whole experiment with just 1,000 ants, it really serves as a powerful illustration. It kind of makes you wonder, what is any small, coordinated, and cooperative group truly capable of when they're faced with what seems like an overwhelming challenge? It's a pretty profound lesson in the power of collective resilience.